name is Yusuke Tsutsumi. In this video, I will present Project 3 Manufacturing Topics. This video is for Georgia Institute of Technology Designing Manufacturing course and will be submitted to Dr. Hassan Rashidi for Fall 2024. Here is the outline of the video. The goal of this project is to present 5 topics from lecture that I found interesting. For each topic, I will give a quick summary of it and explain its importance and some applications. I will then describe its capabilities and limitations. The first topic is concurrent engineering. The goal of it is to minimize product design and engineering changes, as well as time and cost involved from design to production and introduction to the market. It is trying to optimize all elements involved in the life cycle of the product. Some importances is that it increases productivity while lowering costs, and it helps identify and correct mistakes early on in the design process instead of later making changes that are costly. It also reduces the time to the market. Some applications are the product lifecycle management software and the use of CAD models, which allows you to make design changes while making prototypes. Some capabilities is that it has faster design process and it reduces cost and increases the quality of the product. It improves collaboration among different teams. Some limitations are that work must be synchronized and requires time and effort. It must have full support of the organization's management and must utilize all available state-of-the-art technologies. There will be less flexibility in later stages of the process, as the changes will be costly. The second topic is design for disassembly, or DFD. It makes the design so that the product can be disassembled easily for maintenance, service, recycling, or disposal. The disassembling process must be intuitive and fast. Some importances is that maintenance is easier and it reduces the complexity and improves efficiency of handling individual components. Some applications are automotive industry, where bumpers and headlights can be easily replaced. Electronics, where batteries and other parts are also easy to replace to extend the device's lifespan. An example of everyday product that implements design for disassembly is a bike. Removing the wheel from the bike is easy because of the removable fasteners with the use of correct tools. Some capabilities is that it reduces the number of components to make disassembly process easier. It is also eco-friendly as there will be less parts used and reduces the waste with recycling materials. The reuse of the components or materials will lead to cost savings, and the products that are easier to repair improves the user experience and increases the sales of the product. Some limitations are that it requires careful planning so that changing the parts will not affect the functionality of the product. And focusing on DFD too much will limit design freedom, so balance is the key. And using high quality materials may lead to high production costs. The third topic is automated inspection. It is the use of various sensors to monitor the relevant parameters during the manufacturing process. By using those measurements, the process automatically corrects itself to produce acceptable parts. Some importances is that the product inspection at the rapid pace leads to increase in productivity. It is able to adapt to various products by programming or monitoring remotely. Some applications are the automotive industry, where it is used to inspect engines and brakes. Medical devices, where it checks the functionality and quality of the medical electronics. And lastly, the electronics, where it is used to check tiny components like chips for defects. Some capabilities is that it has high accuracy and speed with consistency. It is cost effective with its efficiency and the reduction in manual labor costs. Some limitations are that it may have difficulty handling unique items, which may require human assistance. It requires maintenance to ensure accuracy, and it has high initial investment costs. The fourth topic is deep drawing. It is the process where a flat sheet metal blank is formed into a cylindrical or box-shaped part by a punch that pushes the blank into the die cavity. The image on the right shows how the process works. The blank is pushed to create the drawn cup. The importance of this process is that deep drawn parts are seamless in the design. It eliminates some assembly steps as it produces shape with closed ends. So it is best for products that require to be leak-proof. Some applications are the beverage cans, which this process is used many steps of deep drawing to form its final shape. The deep drawing also is used to create pots and pans. Some capabilities is that it is suitable for long production life cycles, and after the initial tool investment, production costs are very low. It has high accuracy and precision and fast cycle times. Some limitations are that it has high initial setup costs, and it is not suitable for small runs as it will not be cost effective anymore. The last topic is laser beam machining, and I will be focusing on the cutting process. Laser cutting uses a focused high-density energy that melts the portion of the workpiece to its desired shape. It is used to cut sheet components, tubes, engraving patterns, and even more. It is used for various materials such as wood, plastic, and sheet metals. The importance of this process is that it is useful for prototyping because of its precision that allows to create designs with complicated shapes. Some applications are airframes and ships, which they uses the laser cutting to create sheet metals. Electronics, which they use to cut and shape microchips, ensuring precise dimensions. And lastly, prototyping, as I mentioned before. Some capabilities of laser cutting is that it has high production speed compared to other machines. It also has high precision, and lastly, there is no retooling that is required. Some limitations are that it limits the material thickness as it requires more laser power for very thick materials. For many polymers and some metals, harmful gases and fumes will be produced and will require controlled atmosphere processing. It requires high energy consumption, and it also has high initial investment costs. Here are the resources that were used for this project. And as a disclaimer, this video is for educational purposes only and created from the knowledge gained from the design and manufacturing course. Thank you.